Hi everybody. So today we're going to continue our discussion, chapter 3. We'll look at geometry transform. Okay. So geometry transform is actually for us to restore an image which has been geometrically distorted, something like this. So if you look at this image, okay, so you can see that it has been geometrically distorted, means the location has been displaced. So you look at the head by right should be here, but now has been distorted to something like this, right? So so the method is referred to as rubber sheet transform. So what is rubber sheet transform is, here we try to model how the image has been, stretched, okay, distorted. So well, after we model it, then what we can do is we can actually do spatial transform. That is, once you have modeled how the thing has been distorted, so now basically we already have the mapping. So we know that, okay, this quadrilaterals here actually can be mapped to this location. So to do the restoration, basically what we need is to look, if you want to know what is the grade level here, so we need to map back to this point. We go to the distorted image and then we copy the grade level value back to here. And then we repeat that for all the points within this box, okay, according to the mapping equations, which we're going to develop later, okay, which map all the points in this square to this box areas. Okay, and we can actually do that because we know the mapping, this point is actually mapped to this one, and this point is actually mapped to this one, and so on. All right, so something like this. Okay, so how do we actually do the modeling? So the modeling actually, well, you can take a photo of if you have that integration process. So you can take a photo of this. So from here, then you can roughly see how the point has been distorted. And then from there, you can come up with a quadrilaterals like this. This is the simplest form, because we can have more type points, but then the mapping equation will then become more complex. All right. So once we have model, as I mentioned, we do the spatial transform. Spatial transform is something like this that I have explained just now. That is to map all the locations, okay, of the restored image to the location of distorted image where you can find the gray level, and you copy the gray level here. So what you need to do is to fill up all the gray level of all the points here. According to mapping equation, we map to all this location of the distorted image, copy the gray level, and then fill up. And eventually, after you fill up the whole image of IRC, then you get the restored image. Okay, and then why do we need this gray level interpolation? Okay, because usually after we do the mapping, and then we tend to find the location is, we have some floating points here, decimal points here. So meaning that, okay, example will be to visualize this, you find a point here. Okay, if you get the equations, you find that that location is not an integer. That location is some non-integer location, meaning that it is actually in between, because we know that our locations are all defined by integers. So, but usually after you get the transformations, you do the mapping, you get the location which is non-integer. And non-integer simply means it is in between the actual points. So then how do we actually interpret that gray level, find the gray level? Because after all, that is the end results that we want. Copy the gray level and then put it here. But if we get this or this or this or this, we get the gray level. But what if the location is in between them? So how do we estimate the gray level? So that's gray level interpolation. Okay, so we look at the first part first. That is, we look at how we do the spatial transformation. So for spatial transformations, we use bilinear model. So this is bilinear model. It's very much like y equal mx plus c, but now instead of only x, we have r and c. So you want to find the location in this distorted image, the r prime and c prime. So you need to give row and column of this image, the one that you want to restore. For example, you want to know what is the location of 86/86 in the distorted image. So then you will use this equation. But of course, in this case, in order to find this equation, we need to find out the K1 to K8, the 8 unknowns. And for that, we need to have 8 simultaneous equation. And that 8 simultaneous equation can be obtained from the 4 tie points. Okay, which is this 86/86 is mapped to 86/43. All right. So with that, then we can develop the mapping equation. All right. So we look at in this case, the R prime and C prime is 86 and 43, 86/43. And then the R and also the C is actually the RC here, 86/86. So 86/86. So with 1 pi points, we have 2 equations. One from the R prime, one from the C prime. And then you repeat that for the second points. In this case, the R prime, C prime's 70, R prime, C prime 170, yeah, 70, 170. And then the R and C is 86 and 171. 86 R, C 171. And with that, we have second pair of equation. And then here, the R prime and the C prime, R prime 170, this one. So 170. Sorry. Okay, so 170. Okay, and 55. All right. 170, 55, and then the RC is 171.86. I think there's a mistake here. It should used to be 171. I don't know why it changed to 170. This one's supposed to be 170. Yeah. This one is 190. All right. So for this point, 170, 55, 170, 65, 171, 86, 171, 86. And then this one, 190, 170, so 171 times 171, sorry, it's 171. So 86, 171. Okay. All right, so in the exam, you need only to list them, but you don't have to solve them, don't worry. But in grade level, then interpolation, you will need to solve them, but not here. Okay. So next, okay, assume that you have found this mapping equation. Okay, you solve your K1 to K8. So you get your K15, K23 after solving this, and K80. So you get this equation. So now if you want to find what is the grade level for I23 in your restored image, so you just need to put your 2, 3 into this equation, and then you will get what is the R prime and C prime 39. So you just need to go to the distorted image, row 39, column 17, copy the gray level, and then paste into your restored image location 2 to 3. So basically, it's just a mapping of location. Yeah. All right. Now, assume you have something like this, and then now you put in your 2, 3, so you get 41.4, 20.6. So now this is where the challenge comes, where because we know that the grade level is defined for all integer location, but not this real numbers location where you have 0.4, 0.6. These are not defined location. So this is where you need to do gray level interpolation. All right, as explained, so gray level interpolation means you're finding a point which is in between all the actual points. So you need to estimate what is the gray level. All right, so the simplest method is nearest neighborhood. So in this case, the 4 nearest is this, and you find this one, 41.4, you round to 41, 20.6 round to 21. So the nearest is 41.21. So you get 41.21. Okay, so set the value 41.21. So this one, the advantage is easy to implement. Another more advanced is you interpolate on average. So you find the average of the 4. All right. Another, the most sophisticated, okay, the one that will come up in your exam is the bilinear interpolation, where we make use of this bilinear interpolation equation. All right. So to do that, then you need to solve for K1, K2, K3, and K4. And then, you can actually solve that by establishing the simultaneous equation. So suppose you want to look for this gray level 1.32.6. And the 4 surrounding points is here. This is the top left, top right, bottom left, bottom right. So then you can establish the simultaneous equation. So the R and the C. So this is an R prime C prime. So the R prime C prime 1, 2, okay, and 1 times 2. So this is one equation, and then you go, this is for the first point, and the second point, 55. So your R prime is 1, C prime 3, and then the third point, 44. The 44 equals to your R prime is 2, C prime 2, and then the final one is R prime 2, C prime 3. Yeah. And then the gray level is 48. So when you have 4 simultaneous equations, then you try to solve them, and then you get your K1 to K4. So then eventually this is your equations that map the location of R prime C prime to the gray level. So now in order to find what is the gray level for this, so you just substitute 1.3 into R prime and 2.6 into C prime. And eventually this is what you get. So you get something which is non-integer. Again, as we said, the gray level should be in integer as well. So you round to the nearest. Okay. So we look at an example. Okay, page 36. So you're required to perform geometric transform on specially distorted image. So you have determined 4 time points. So this is the 4 time points. So you are required to list down the 8 simultaneous equation using this bilinear model. So we use, so 1 time points give you 1 pair of equation for R prime and C prime. So the first one, we look at this, the R prime, C prime is 8643, 8643, and the R and C is this 8686. And then the second one, okay, the R prime, C prime is 70, 170, mapped to this point, 86171, 86171. Okay, so the second pair, the third one, the R prime C prime is 170.55, 170.55, and then the RC is 171.86. And last but not least, the fourth pair, R prime C prime 190, 170, 190, 170, and then the R and C is 171, 171. All right, RC. So this is the 8 simultaneous equation. Okay, it says that now you have, for one of the quadrilateral subimage, you obtain the following mapping equation. So So now you are required to look for this I10. So your R is 1, C0. So you put your R1, C0. So then you get your output as the R prime is 3.3 and 5.3. So you notice that the answer is non-integer. So therefore you need to perform grade level interpolation. So the questions ask for 3 different ways to do it. One is the nearest neighborhood. Okay. So you're given 4 nearest point, which is the top left 76, top right 78, and bottom left 72, and this. So to let you visualize better, so put it here. So this top left 72, 76, sorry. This is 78. Top left 76, top right 78, 76, 78. And then 72, your bottom left, bottom right 70. So the questions will not actually tells you what is the coordinate, because the coordinate depends the answer that you get. You just say the 4 nearest point. All right. So, and in this case, yours is 3.3, 5.3. So 3.3, 5.3 is roughly here. Okay. So then obviously this one is 3.5, it's 3.6. So it's all, when you round this, so the column become 5. And then 3 round to 3. Then 1 row down is column row 4. And then 1 column to the right is 5.3, means go to 6. So this in between 3 to 4, and the row is between 5 to 6. So your job basically is to determine what is the grade level of this point. Okay, so the first one is nearest neighborhood. Nearest, of course, then you look at the nearest. If you round this become 3. 3.3 round to 3, 5.3 round to 5, so 3.5. So according nearest is 76. If nearer neighborhood average, you take all 4 divided by 4. So you take all the 4 points, 76, or you add them and divide by 4. Yeah, the most marks goes to the most challenging one. You need to use the bilinear interpolation. So you need to establish the 4 simultaneous equation. So your R and C. So R prime, C prime, which is 3, 5, 76. So 3, 5, 76. And then R prime, C prime, 3, 6, 78. So 3, 6, 78. 4, 5, 72. 4, 5, 72. 4, 6, 70. Yeah, 4, 6, 70. So then you have to solve simultaneous equation. So you can take the first and the third. So the second and the first. So you take this to minus. Then you find that the K1 will be cancelled off. K4 also cancel off. K4 minus K4, K1, 3, K1 minus K5. And K2, 6 minus 5. And then K3 is 6, 3, 18. 5 times 3, 15. So 18 minus 15. So, and then 78 minus 76. So you get a shortened equation, only K2 and K3. And then you repeat the same for third equation and fourth equation. You take the fourth minus the third. The same, K1 will cancel off each other, and K4 cancel each other, left only K2 and K3. So it's 6 minus 5, K2, and then K3 is 24 minus 20. And then here, the right side of the equation, 70 minus 72. 70 minus 72. Okay, so this is a second equation. So then you take the second equation minus first equation, so that you can cancel off your K2, left only K3. So you get K3 negative 4. Okay, so once you have K3 negative 4, then you can use either equation 1 or equation 2. In this case, I choose equation 2. You replace K3 as negative 4. So negative 4 times 4. And then you can solve for your K2, which is negative 2. This one bring over here. become positive, so become 14. Okay, so next you can, just now we take pair like this, so now we take the alternate. So we take 4, 5 minus 3, 5. Okay, this equation minus this equation. Okay, so you get K2 and K4 offset each other, left only K1 and K3. Okay, but we already have our K3, negative 4, so we replace negative 4 here. So then we can solve for K1, which is actually negative 4. This one, bring over, come 16. All right. So sorry, this is not negative 5, this is 5. A typo mistake here. Okay. Right, and then we can make use of this equation, 3, 5. Okay, because we already have K3, K2, and K1, 1, 2, 3. So we just plug in the value K1, K2, K3, and then we can solve for K4. Right? So eventually your K4, you do the, okay, you get 18. So now you already have K1 to K4, then you have your full equation. Now you're ready to plug in your R prime C prime 1, 0. Sorry, R prime C prime, which is 3.3, 5.3. So you put in 3.3, 5.3, and then you get 75, round to nearest 75. So that's basically what this is all about. Okay, so thank you very much.